Today I would like to show you how a pretty formula for pi can be derived. It's not particularly useful, but it's pretty, and I tend to like pretty math much more than I like useful math. Wikipedia says the formula was discovered by this fellow whose name I can't even begin to pronounce, so I'm not even going to try. Sort of like how Kurt Angle wouldn't try to beat Scott Steiner at the Sacrifice pay-per-view, according to Steiner's infamous math promo. In the past, I liked to do math with colorful fonts, but today I want to remind us that almost all the math most of us know was figured out long before color movies came out, including all the math in this video here. In fact, it was long before movies of any kind came out. Though it may seem odd, let's start our derivation with this expression here. Negative I times the binomial I plus 1. If you multiply this expression out using the distributive property, you get 1 minus I. And if we divide both sides by I plus 1, we get an interesting formula for negative I. Next, we substitute negative I into a much less interesting formula for negative I. 0 plus I times negative 1. Why the heck would we do that? Because then we could use some trigonometric formulas for the angle negative pi over 2. One of these formulas equals 0 and the other equals negative 1. And now our formula looks much more complicated, but at least pi is showing up now, which is something we need. Problem is, we're seeing it twice. Thankfully, what I would call the most handy formula in the history of complex analysis can give us a nice substitution, which changes these trig functions into an exponential. And that's where most of the magic happens, because our formula that we made much longer and uglier now looks simpler and shorter. That may be my favorite thing about mathematics. When someone, somehow, knows how to make something look worse at first in order to later simplify it and make it look better later. It really is like magic. Next, we just move the I to the other side of the pi and remove the parentheses, because that makes things easier for me. And now we use the fact that I times I equals negative 1 to use a substitution. We can replace the I by negative 1 over I and do some algebra to move the I to the exponent's denominator. At this point, things seem pretty clear now on how to isolate pi. Just take the natural log of both sides and multiply by 2i, and we're done. Looking at the finished formula, I just love how there's a 1 minus I and a 1 plus I as a fraction here. Gives it a real balanced look. It's still not as good as the formula e to the pi I plus 1 equals 0, but few things are. And I think that's enough for today.